In 1947, 3 scientists at Bell Labs invented the transistor. The transistor performed the same on or off function as vacuum tubes, but was much smaller and more reliable. Transistors were made with silicon and tiny wires. Silicon is a semiconductor. If a small voltage is supplied, it will act like a conductor, allowing a current to pass between wires. If there is no voltage, it will act more like an insulator, blocking the current. This characteristic of silicon is what enabled transistors to speak the binary language of computers, and would make silicon the foundation of the computer industry. The next step in miniaturization occurred in 1959, when Robert Noyce and Jack Kilby, engineers for rival transistor manufacturers, independently came up with breakthroughs that led to the same revolutionary idea. An entire network of electronic components, transistors and all, incorporated onto a single chip of silicon. This great innovation in electronics was called the integrated circuit. In 1969, 5,000 integrated circuits made up the heart of each of 2 identical computers. One on the lunar orbiter and one on the lander. For their size, these were the most powerful computers on Earth, or off. As Neil Armstrong took one small step in the lunar dust, Ted Hoff, an engineer with the Intel Computer Chip Company, was making the last great leap in miniaturization, developing an idea that would put an entire computer on a chip of silicon, the microprocessor.
It was the invention not just of integrated circuits, but of a particular kind of integrated circuit, the microprocessor, that made today's personal computers possible.
Hoff had been told to design 12 separate integrated circuits to make a Japanese pocket calculator. He suggested placing the entire processing unit on a chip and programming it just like a computer. Intel developed the idea, and by 1970, they had a working model of a microprocessor. Computers